Determine the sum to infinity of the following infinite series where the absolute value of x less than 1. Let us begin. So we're going to name this series. So let's name it as S infinity, which denotes that we have the sum of the infinite number of terms. We have the first term as 1, followed by 3x, then we have 6x squared, then we have 10x cubed, and the rest of the terms. Now this particular series, this is not an arithmetic series. That's because we do not have any common difference here. Also, it's not a geometric series because there is no common ratio. Now, what we can do here, we can check whether if it is an Arithmetico-Geometric series or not. For this, what we'll do, we're going to consider the constant terms. So let's say we have 1, 3, 6, 10, and the remaining terms. Now, do these terms form an arithmetic progression? No. So these are not in arithmetic progression. They're not in arithmetic progression. However, if we consider the variable terms, that means if we consider 1 as the first term, followed by x from the second term, x squared from the third term, x cubed from the fourth term, we see that this particular sequence is going to be in geometric progression with the common ratio equals to x. Now we have an infinite series where the combination, that means we can say 1, 3, 6 and 10 are not in AP, but 1x, x squared, x cubed, these terms are in GP, then in this particular case, we cannot say that this is an Arithmetico-Geometric series. So what we'll do, we'll take 1 and we're going to multiply throughout with x. In other words, what we are saying is we're going to multiply x with each terms of the infinite series. So multiplying x with the first term, that gives us x. Add 2. Multiplying the second term 3x with x gives us 3x squared. Then we have 6x squared. Multiplying with x gives us 6x cubed. Added to the rest of the terms. We're going to name this as equation number, that's series number 2. Now what we'll do, we're going to perform a subtraction here. So let's subtract 2 from 1. That means on the right hand side, we have 1 minus x. So this gets multiplied to sum of the infinite terms. This will be equals to 1 added to. Now what's 3x minus x? That's 2x added to 6x squared minus 3x. So that's 3x squared added to 10x cubed minus 6x cubed. So that's 4x cubed. Now here we get a new infinite series. We're going to name this as number 3. Now this particular series, this is an Arithmetico-Geometric series. That's because here, if we consider the constant terms 1, 2, 3, 4. So here we see that these constant terms are going to be in arithmetic progression. And we see that the variable terms, that means 1x, x squared, x cubed. So these are going to be in geometric progression. Now because we have an arithmetic progression and a geometric progression which forms this series, infinite series number 3. Now we can say that 3 is an Arithmetico-Geometric series. So here what we have done is we have transformed an infinite series into an Arithmetico-Geometric series. So rest everything remains the same. All we have to do is take the common ratio, which is x in this case, and multiply each terms of the infinite series 3. And that's going to give us x multiplied to 1 minus x times s infinity. So that's going to be equals to x plus 2x squared plus 3x cubed, and we have the remaining terms. Now what we'll do, we're going to subtract. So let's name this infinite series as number 4. Now this time we are going to do 3 minus 4. So on subtraction we get 1 minus x whole squared multiplied to sum of the infinite terms. So this will be equals to 1 added to, so 2x minus x, that's x added to 3x squared minus 2x squared, so that's simply x squared. 4x cubed minus 3x cubed, that's x cubed, and the rest of the terms. So now we have 1 minus x whole squared times sum of the infinite terms. Now the sum on the right hand side, this infinite sum, this is a infinite geometric series, and we know the infinite geometric series whose first term is 1 and the common ratio is x, its sum is given by the first term divided by 1 minus the common ratio. That means that sum of the infinite terms comes out to be 1 over 1 minus x whole cube. So this is going to be the sum of the given infinite series.